In this lecture, we would be talking about the use of geosynthetics in ground improvement. This is a continuation of the previous lecture, and what we would be seeing today is that what are the types and functions and applications of geosynthetics. We will also see what are the principles of reinforced soil. This geosynthetics is a big family of polymeric materials in which you have two types. One is a permeable members and non-permeable members, and permeable members means they allow water through them. As I just mentioned, in many of the ground improvement problems, the use of water is something very serious, and the presence of water, which leads to a lot of difficulties because it leads to poor water pressure mobilization and all that. So, if you have some sort of textile like this, which can be a geotextile where the water can really be permeated through this, then it is much more simpler. So, in this we have many types of materials. One is called woven, the other one is non-woven, other one is knitted. So, you have, depending on the type of the manufacturing, the process in which it is done, this is classified whether it is woven, in the sense one material over the other, and then it is simple weaving that in India we are used to, that textile mills have this. Non-wovens, either they are heated, knitted is another method. So, we have another family called geotextiles. We also have geogrids, what you have here, like this is called a geogrid, and this is also a geogrid, and many of them have they are extruded, sometimes stretched and sometimes welded. In fact, welding by laser is also possible. We have different types of materials here, which are essentially geogrids. Geogrids, we use it for the conditions where we need very good tensile strength. Then we also have what we call geocomposites, in which many combinations of geotextiles and geogrids and geomembranes are possible. This is one case in which you have a geotextile also as well as a geogrid also. So, you have many, you can just see that here you have a geotextile in between, and you also have a geogrid here. So, the advantage would be that so this is another composite in which you have a geotextile and also a geomembrane at the bottom, and this is another one where you have a geotextile on both sides and also the netting. It can serve for drainage applications very well. So, you have some of these materials, and non-permeable means geomembranes. Actually, in the case of textiles, the permeation is water permeation is possible, or even permeation of any of the fluids is possible. But in the case of geomembranes, which are something that are impermeable, you have like this, which are the permeability is very low, and they are all from different families. One is called thermoplastic, the other one could be elastomeric, and even sometimes we try to coat the materials with bitumen to see that the permeability is quite low. And we also have what is called geosynthetic clay liner, in which you have a geotextile on either side, and you have a bentonite mixture powder inside, and that also provides reasonably low permeability or very less permeability compared to permeable textiles. This could be in the range of -2, or this could be -8 or 10 or 14, in fact 14 centimeter per second. It could be very low, whereas it could be very high here. And another information that we need to have is that, as I just mentioned, these are all the polymeric materials which are the which are combined together by CH bonds, like carbon hydrogen bonds. It is a molecular chain of carbon and hydrogen bonds, and depending on the manufacturing process, we will see that they can have different properties, like say for example, if I say polyethylene and polypropylene, we say that they belong to this family of polyolefins, and the densities are 0.9 to 0.95, the melting point is 110 to 170 degrees, and strain at ultimate tensile strength is about they are stretchable, like for example, you take a geotextile, it can have a very strain could be little higher, creep also could be higher, and some polyester materials the specific gravity is higher, or the density is higher, the melting point is also higher, then the tensile strength you can get at 10 to 15%, like so for example, you take a stiffer material, it will reach the ultimate tensile strength in a very fast manner. and also the creep could be low. So, for example, in some applications we do not want lot of creep, and so this is very important that we should also choose the materials in a proper sense. So, one should ask what type of polymer you have in a particular geotextile. Then functions, we have seen that couple of functions are there which are like, say for example, if I say filtration, it only allows the passage of fluids preventing the migration of soil particles. So, you have a geotextiles and geocomposites here. Then the drainage, transport of fluids, like say for example, this is a geonet composite. Then filtration is just a geotextile or a geocomposite can be used, and separation is nothing but it just prevents mixing of two different soils or materials using geotextiles or geocomponents. You can do this by any material which can be used for separation. Essentially geotextile is used because it is much cheaper and then prevents the mixing of both the materials. Then you also have to protect, so protection layers are there. So, for example, if you take landfills, you would like to avoid damages to a structure or a material or another geosynthetic. So, for example, geomembrane is there, and then if the geomembrane gets punctured, then it cannot provide that impermeability characteristic which is required from it. So, what you do is that you put some sort of like a cushioning material which is called a geotextile, which can be used to protect it, or you can put a layer of sand and again put a layer of geotextile, because that is also useful. So, it is useful to protect some materials which can get otherwise damaged. Say for example, it could be any geocomposite. So, you can prevent it by any means so that it is protected, particularly in landfills. If some damage occurs in landfills or geosynthetic products, it is very difficult to repair them. So, it is very difficult to repair in some places in like in landfills where the geosynthetic materials are about say 30 meters or 50 meters deep, and already the layers are inside, and it is very difficult to remove any of them or repair them. So, what we do is that we try to take utmost precaution in trying to put some more additional layers as protective measures. Then as I just said, impermeable member is an important member of this family, particularly in the form of a geomembranes. We would like to see that the water is not allowed in some cases. Say for example, leachate it percolates in the landfill, it should just go to some nearby leachate collection system and should drain off. It should not go down and then contaminate the groundwater. So, we use for the minimization of permeability, we use geomembranes. We use like we say that they are either geocomposites or geomembranes, they are essentially fluid barriers. Then very important thing is reinforcement of walls and slopes. This is actually of course it provides tensor forces in soil using geogrids and geotextiles. Of course, this is a bi-oriented geogrid, and we will see some of them. Mono oriented is also possible. So, reinforcement of soft soil, it increases the bearing capacity using bidirectional geogrids which are like this, or even it can be like this, where you have a bidirectional geogrid can be used. This also can be used. It is called some product from Secugrid, which is quite a very good material, and it can. So, in some even you can use a geocomposites because you need also a drainage at the bottom. So, you have a geotextile as well as geogrid, and it can also be used for reinforcement of concrete and asphalt roads, because the fatigue resistance and is very important in the pavements, like both fatigue and tensile resistance like can be provided using the geogrids. Say for example, the pavements crack because of the fatigue and rutting. Two criteria are there, failure criteria, both can be designed to see that these failures will not occur, and if you use a geosynthetic material, how they reduce both fatigue. Fatigue is nothing but the accumulation of strain because of the repeated action of traffic, and rutting is the formation of depressions or permanent deformations which can be avoided using this geogrids or geotextiles or any of these members. Then another important application is, or the function is, the erosion control of surficial stabilization, or superficial stabilization. Actually, in many of the slopes, detachment of the soil particles is an important problem, and because of the rain and runoff and other issues. So, we try to encourage them using geomats, geocells or biomats and bionets. One can use a lot of coir, say for example, geotextile material is here, jute geotextile material. One can use some of this material that you have here, all the geotextile material one can use quite very well in many of those applications. Geotextile materials are here. So, this is all natural materials. The advantage is that once a vegetation grows and then forms a layer of erosion control, then these materials can go off, but still you have a nice soil cover. Then another important thing is what is called confinement. The reinforcement also provides some sort of confinement. Nowadays you have a geocells which are very good, which can provide good confinement, and so actually the notation is like this, there is we have what is called International Geosynthetic Society, in which they have identified a proper notation to for each function. Like say for example, you have a separation function, it will be like this. You have a material like this, this is a separation function, like this is one thing, it acts as a separate layer. Then filtration means it allows only water to go out of the material. Then this is reinforcement, like tensile force is applied in the reinforcement, like tension is applied. Then this is a protection layer, like it does not allow the bottom material to get damaged. Then waterproofing, like a geomembrane, it just collects water. Then drainage, you can see that the water particles go out of this. Say for example, you have a retaining wall, next to that you need to provide drainage. So, you have a nice system like that, and the drainage is nicely allowed, and then the rainwater gets collected at the bottom of the retaining wall. Then erosion control, as I just mentioned, this will just nicely collect all the water without slope getting eroded. The slope should not get eroded, and if the slope gets eroded, then it is a serious stability issue. And if you have a geotextile or a proper riprap, normally the conventional solution is to provide a riprap, and the riprap prevents, if you have a geotextile as well, prevents the erosion problem. Then the applications are too many, like it can be used in dams, reservoirs, and it can be used in liquid waste, solid waste, canal linings, then road network, railways, retaining walls, like as I just mentioned, you can have a retaining wall system with reinforced earth. Then erosion protection, even in tunnels it can be done as drainage systems also. These are all some examples that we will see, where see this for the reinforced earth wall, you have layers of see this is a backfill, this is actually we call it a backfill, this is a wall fill. Wall fill means the wall, the fill that is next to the wall, then this is a drainage material, and this is a reinforcement, and this is a facing element. This is one typical application that one can have. This is in the case of bridge abutment, where you have a lot of applications like this, where you have say 6 to 7 meters is required as a grade separator, and if you have a reinforced earth wall like this, it is going to be very cost effective. And fortunately in Indian conditions, people have realized that this is very useful, and it is very fast as well as cheaper. People have been using this technology very well for the past 20 years in India. Then this is a case of a reinforced slope, in which you can construct the slope to about 70 degrees, which is not otherwise possible by soils alone. You can see that this is another type of example, and this can also is also a reinforced slope. Then soil can be restated by reusing the same material. Sometimes if this is a slip that occurred in the case of a slope failure, this is actually the failure surface, you can really repair that, use the same filled material, put a geogrid properly, the one can repair it in some sense very well using the same material and also using geogrids. So, here there was a problem of stability and then it collapsed. Here we do not have the problem of stability, because reinforcement prevents that formation of failure surface. We have a failure surface like this, but that is not there if you have a geogrid reinforcement. Then this is some extension where you would like to widen the roads, like you can see that you want to increase the right of way, like this, say for example maybe 4 meters is available, you would like to make it to 10 meters or something like that. This is possible. This type of applications are too many in hilly areas. In fact, there was 42-meter high wall construction which I visited about some time back, where to provide access to the hilly areas and to provide facilities for the traffic that is visiting that area, they have made this sort of wide roads and also parking places in some places. This is about noise barriers, which is again you have a residential locality here, and then you have a lot of noise nowadays coming from the highways. When the speeds are of very high order, like more than 150 kilometers per hour, then it creates lot of noise. So, you have a noise barrier system as well here designed. This is another example where in the case of railway embankments, the earthwork can be saved. If you are able to construct the slope in this manner using the RE wall, reinforced soil technique, you are able to save this much of soil, and it is going to be much more stable as well. So, essentially you can design some of these things in a very comfortable way. This is in the highway embankments, you can see that the area of cross section is so much could be saved. In the case of pavements, that is what I was telling, that it is possible to have rutting failures, as well as rutting failure means deformation failures, and as well as fatigue failures, which are because of the repeated application of loads. Both can be seen that you have a higher resistance with this geogrid material, and you also have a drainage here. You can just have a geotextile here, then the drainage is there. So, all the problems that the road has, whether the subgrade is poor, then this material is poor, the loads are high, all could be handled by a proper combination of geogrids and geotextile. This is some place where they are trying to try this separation function. Of course, as I just mentioned, it has been used quite extensively. Then you can also have separation plus reinforcement also in some applications. This is a high wall, you can have 9.5 meters high wall, again a 8 meters high wall. In fact, the total height in this case is about 17.5 meters, and if you want to really conventionally go for this type of this height like 17.5 meters, you should only go for counterfort retaining wall, which is very expensive. Like if you want to go for 17.5 meters retaining wall, the base width could be about 0.3 H, like which is about 4 to 5 meters, and then again it is a the concrete quantity will be very high, steel quantity will be very high, but here you have simple reinforcement which is just horizontally acting, and then you have a backfill, you have a facing like this, that is it. I mean it will be very cheap, maybe 30 to 40% cheaper compared to a regular retaining wall. So, this is how it looks like at the top, where you just try to take this material filter cloth. So, this is a close view of that material, and this is the same view. Reinforcement in the case of roads, it can be done like this, where you have a granular subbase material, you have a subbase material, and then you properly cover it and put a geogrid like what you have here, and put the backfill soil or the whatever is a subgrade material, subbase material, and then roll that, and then you have a very good properties. This is another interesting application. We are familiar with this are all fiber, this is actually the reinforcement. If the force of application is like this, this is the reinforcement, there is a friction between the soil and reinforcement, this is in the opposite direction. So, the force is being resisted by this reinforcement. You have a, so soil, the friction between the soil and reinforcement is acting in the opposite direction. So, once you provide this length and spacing of that, then there is no problem at all. So, what we have is that this is, we call it a preferred reinforced soil, but in some places like you can add fibers to the soil, and then that also leads to cohesion. You can add lot of waste materials to soils and they increase cohesion. This is one case what is called Texol in France, where the wall was constructed with just this material alone, like they used a lot of material like this. Then since it has good cohesion, it will not collapse, it will the height it can retain about 5 to 6 meters easily. So that is much cheaper than going for this type of materials also. So because the people have been exploring different methods of using this fibers and reinforced soils and all that. This is a reinforced earth wall, like you can have facing here and all that. This is actually a lining and drainage applications. Here what you are trying to do is that capping of an old waste dump. A waste dump, so for example, now in India also we have a lot of waste dumps. The count is not easy, there are so many waste dumps, and we should see that the odors, the gases, the or whatever is that the problem because of that should not be to the nearby public. So people have to cap it, means they have to close it. So this is what people use it, they close the capping of a old dump is something very needs to be done systematically, because it leads to a lot of problems. It should not the old dump should not lead to pollution, both air pollution as well as water pollution. This is actually an erosion control mats here, one can have a geotextile coir material and all that. This you can see that there is a slope is very nicely finished. So some more applications that I would like to mention, hydraulic engineering applications. Actually we covered some applications in the previous class. So waterproofing of dams is very important, waterproofing of canals, reservoir liners and floating covers, tunnel waterproofing and rehabilitation, pipe rehabilitation. Even this is all the, like one can say that in many of these applications we have different types, like transportation applications are there just for roads alone. For landfills only we have applications, we have even hydraulic applications, we have even structural engineering applications, where as I just mentioned geomembranes can be used for waterproofing. Okay. So in the case of waterproofing, like normally masonry, concrete and earth dams are used, and so for which if you want to have waterproofing you need a good geomembrane. So it's for waterproofing we provide, and particularly there are many dams which are old, like say for example 50 years, they have lot of leakage and sometimes excessive leakage. In fact even in India we have many dams that have this leakage problem from the upstream and all that. What happens, you are expecting that the dam stores water, but then if there is a seepage then it cannot store water. So sometimes it can be even excessive leakage. So there are many methods that people have tried. In fact it has been done in some place in Maharashtra, some place in Tamil Nadu, where they used geomembranes to rehabilitate old dams. Like this is a typical example, it is a upstream face of the dam starts leaking. So normally you should not find any water flow here like this, that is wrong. So what you do is that you put a geomembrane like this, lining of a concrete dam, you can put some sort of geomembranes here, see that it is not there, and the water is not permeated. So this is a typical figure again. Then like this is another one, lined earth dam. Say actually in some earth dams we provide riprap. So before the riprap you can provide a geomembrane to see that there is no leakage. Then waterproofing of canals, actually in many of the places in India at least we have what you call in many of the water supply and for irrigation and all that, for drinking and all, for particularly irrigation canals is through the canals, and they have lot of quantities going through them, and if there is a problem of seepage then it is very significant, like say for example if 20 to 30% is through the leakage, then it is going to be very risky. So we need to have some sort type of liner which is a geomembrane or a GCL, and there are many agencies even in India they are doing it. like this is a simple example, lining a canal before soil covering, like you can see that this is a gem membrane, yeah, this is one, yeah, they are trying to, this is a site actually, this is the liner. So, you can see here more clearly that you have a gem membrane liner here. Then you can see here sometimes they are very durable actually. Gem membrane canal lined after 18 years, canal liner, its life is about more than 18 years, and after the liner if somebody sees the flow like this, it could be there is no leakage. What it means is that, so many of these situations are there in Indian conditions, one should be able to use the geomembranes very well. Like even it is possible to line canals which have lot of say water flow already. So, people have methods of doing this lining. The geomembrane lining is very essential. It has been useful for storing of the tanks actually, like ponds, then whatever is the waste water that you have, sewage sludge, agriculture products and hazardous liquids and all that. And the advantage here that we have is that there are some issues that we have here, that the liquid depths are there and the slopes are there. They should not have let us say for example, this is a potable water which is stored, and then the potable water should not be leaking. So, you need to have a geomembrane for that. Then see, the thing is that you should be very careful, as I just mentioned earlier, the friction between the soil and geomembrane could be very low. So, it leads to some sort of it floats, like if there is no, like if there is, because of slightest pressure it can get lifted up. So, one should be very careful, and so that is the reason what you have what is called floating failures will be there, like floating GM cover. I mean the geomembrane should not get formations like this. That is one important worry in geomembranes. They have been very effective, but then if there is some air gaps and all that, it just gets lifted up, then there is a problem. Here also one where so this everything is a geomembrane area, but then in some place it got huge GM bag transporting potable water. So, this is one type. So, there are many issues that one can have even in tunnels, like say for example, you go to northeast and other places where they are trying to put railway lines through tunnels, and lot of leakage is there in tunnels. It is very difficult to handle. See, you are trying to construct the tunnel and then the water starts seeping, it is very difficult to handle. So, what we do is that we have a system like that, where you have a shotcrete. First you put some shotcrete, means nothing but cement plus concrete, then you have a thick geotextile, you have a geomembrane, you have a permanent liner. So, you can have an arrangement like this, which can be then you collect all the water like this. Say whatever is the seepage water that can come here, there is a geotextile that one was it's provided. So, take all that water through this geotextile and also this sort of drains, and do not allow this water to go on this highway. Say for example, this could be a train track. Okay. So, one can see that such problems can be avoided using this geomembranes. Even in some places tunnel rehabilitation, like say for example, in some places you can't use the tunnels because of the excessive leakage, and leakage also leads to instability. So, then what we do is that this sort of, say this is a typical case, then they try to put a layer of geomembrane and all that. There is a systematic design here. So, these tunnels, or whether it is for the water supply or for whatever purpose we have, we can rehabilitate. This is another example, pipeline rehabilitation. In fact, in the olden days people were having cement pipes for carrying water, or even they could be lined with bricks and all that, like this. They were, if you expect them that they can carry water, it is not possible. what happens is that all the water gets lost in seepage and other things, and even this whole area gets damaged. So, what we do is that we try to line them with some you have coatings, you have slip liners, you have curing in place, and there are in situ liners like this, pipe within pipe. So, there are so many techniques that one can have, and so now I would like to show how these materials like fibers and tapes are all made. Okay. So, for example, you have a number of companies of production of this plastic material. It is called polypropylene fibers, for example, in this case, like you have a thin fibers on this material here, very thin materials here, fibers, thin fibers, like what I saw here, like they are all thin fibers. You can see that they are all very thin fibers. So, they are all so the this is about fibers. Even you can have a material like a tape, for thick material, which can be in the form of like this, and so like whatever you have, either a geotextile or something, one can have a one that goes through that. What you see in the black color is something that is little later. So, you push the material and then it comes like this. Then you have, as I just mentioned, different types of weaving, like again you have a typical say for example, we are used to this weaving industry in India, where they do this weaving in of sarees and other things. Here same thing, weaving is done using machines, where you have all the fibers stitching in a woven form, and it is not single multi filament actually. See, there it could be single filament one and then it could be multi filament weaving. See, you can see that it is a big one. Okay. Then this is again polyethylene, again woven fabric here, you can just see that. Again one more type. No, you are looking at a very micro level examination, then only it is possible. You do not see that in a naked eye some of these arrangements. You have to look at it very carefully using a microscope, and you will be able to see some of these differences in indentations and all that. This is again one more type. This is monofilament, like in all single filaments, and they are all woven together. So, that is about geotextiles. Geogrids, like this is one type. These are laser welded, it could be like this. The welding technology has improved so much. You have X-ray welded. So, these are all some materials, because see, the thing is, the advantage of the geogrid is that in the case of geotextile, when you provide earthquake forces acting or any lateral forces acting, this will be like this. The resisting force is only because of the friction between the geotextile and the soil. But in the case of geogrid, there is a small extra length here, which is called some thicker one, that provides a bearing resistance. So, a little thicker here. So, like this, a number of materials are there, they provide a bearing resistance in addition to skin friction or the frictional resistance here. So, this is much more efficient. So, one can do a punching of the holes in the member to get this done. This is what I was just mentioning. In the case of grids, you have uniaxial members, and this is useful for RE wall applications. Actually, some of these slides I must thank my friends from Germany, like Landesgard, Banstall-Beyen, who have supplied some of these photos and some of this material. Dr. Gartung and Dr. Helmut Zanzinger, they are able to get lot of equipment and lot of experimental facilities they have. They during their I mean they have done excellent work in geosynthetics, and I was in their organization for 1 year in Germany, and I collected a lot of information when I was there, and now I am using some of this material for the presentation of this in these lectures. This is what I just say is a geogrid biaxial, and knitted structure is one thing. You can see that it is like a some knitting. So, nonwoven production, see wovens are one thing where you weave around and then get that. What is nonwovens? Nonwovens, again you should get this. Here again there are a couple of important points. We should know what is a fiber composition, what is the basic material there. Then it forms a fleece of oriented fibers, and multiple layers of fleece for desired MUA. MUA means mass per unit area. Actually this mass per unit area is an important property required in the case of nonwovens, where say mass per unit, say for example we know the paper you know, you say it is 80 GSM, 80 grams per square meter, or you take a silk saree, you say about 200 GSM, means it is it denotes the quality of the material, like you know you are having a very good density of paper or any of the cloth material, then it shows that it could be much stronger, durable and all that. So, here also we try to characterize some of these nonwovens using this term called MUA, which is nothing but mass per unit area. We measure it also. So, what we do is that we bond them mechanically or thermally, either you use a heat or mechanical bonding is done to get a product, like you know. So, this is all you know in one place. So, these materials stacked in one place. In fact, I visited one of the plants in Luxembourg, it is called DuPont plant, in which people have lot of you know geogrids, geosynthetics are all manufactured there. So, these are all some materials that are stacked here. You can see that staple fiber nonwovens, you know orientation of fibers is something that they are doing here, some processing is being done. Then fleece of oriented fibers, like you know when you just rotate in this high speeds and all that, you know, and then stitch it and then you know join them together, they have a material like this which are formed. Yeah, then this is all like this, then it becomes like this. This is all you know, remember that they are all plastics, polymer compounds. Then there some lot of conveyor belts, and there are a lot of mechanical processing is done, and needling device, sometimes needling device is also there, you know, this is for needling device. So, needle punched, nonwovens needle punched, actually this is another one where you know this is another again one technique that we use, and you have to see that this at a very close examination, like you know very micro level examination, you will see things like this, but in the gross sense, actually I do not have here, yeah, I think this one. So, we have some material which are nonwovens plus heat bonded. If you just look at micro level, the possibility is that it looks like this. Again one more close view of the same thing. Then you also have extruded mats, like again random drain core, you know. So, for example, as I just mentioned, for prefabricated vertical drains we need to have drainage core, you know, like we have a geotextile as well as a geo filter. So, this is a drain core, you know, you can see that we have a drain core also here at the center, like this is a drain core. Okay. So, so this is, and either side you have a geotextile, some of this material also can be manufactured in this manner. Some important characteristics one should remember was that you need to have some mechanical properties understanding, then you should also understand that say for example, mechanical properties means strength and stiffness. Strength is nothing but I just mentioned that the ultimate tensile strength. Say for example, you take this material and test it, you have its short term tensile strength, so for example, immediately the material is manufactured and then it is ready for delivery and testing and all that. So, you have a mechanical short term testing where you have to get its ultimate tensile strength and also stiffness. The mechanical properties of tensiles, there are so many we have, like it's we will see some of them in a detailed way. Say for example, it's apart from strength and stiffness, it's perform the other properties like size, like say for example, apparent opening size of the geotextile. The geotextile allows water, but how do you characterize the opening size of this? It is called apparent opening size, say that comes under hydraulic properties. So, there is also short term and long term. Actually, many of these materials we need to have understand that there are two considerations here. One is a short term stability and long term stability, like you should be able to work immediately as soon as you apply. It should then long term also. So, for example, if you are using for 10 years or 20 years or 30 years, the mechanical property should be very good. So, for example, if I am using a geogrid for in a particular application and then the design life is 30 years. So, I should design, I should know what is its tensile strength at the end of 30 years. So, we have some methods to calculate, if you know the tensile strength now, what should be its tensile strength after 30 years based on testing, like people have done some durability studies or long term testing. Based on that, we have some correction factors, like say for example, the based on the time and the temperature, even the, say because many of them are polymeric materials, they have temperature corrections also, like higher is the temperature, higher will be the creep. As the creep is there, definitely the tensile strength will come down. So, if it is in an application which needs long term applications of say 30 years in a hot climate, maybe you have a laboratory strength of say for example 50 kilonewton per meter for this value. 50 should be divided by say 1.3 because of temperature or 1.4 because of something, like temperature is one thing, then time duration is another one. The third one is mechanical damage. Say for example, you may have it in the lab field, but then when you install it in the field, we should just see that there is a damage factor also considered. So, all these things we need, and we calculate this mechanical properties as well as hydraulic properties. Hydraulic properties I just mentioned, it is just the apparent opening size and even the permeability. Actually, permeability we call it, say for example, in some of these materials, thickness also plays a role. If the higher is the thickness, higher is the flow. So, we use a term called permittivity. Permittivity is nothing but the permeability divided by the thickness of the material. So, if you know K divided by T, then we have that as permittivity. Okay. Then we also have what is called transmissivity, like in the sense like the filtration or the permeability is required in this line, but the drainage, how much of water can be through this material can take, it is called transmissivity, and it is nothing but K into the thickness. We call that as that important parameter. It is again for drainage that is required. For the filtration we need permittivity, we try to say in terms of the permittivity, and for drainage we say in terms of the transmissivity, and in both cases we need the thickness, because thickness is an important variable in many of these things. Then durability studies, are like as I said, many of these chemical materials, they are all temperature dependent, installation conditions, aggressive chemical environment could be there. So, if there is some lot of chemical industries there, one should use proper factors, it should not get damaged. Actually what we are essentially looking for is that, like this material should have its required tensile strength, whatever is the condition you have designed. Say for example, 50 kilonewton per meter is this number, but in design you will get a number that what is required is maybe 10 kilonewton per meter. So, you have a factor of about 50 by 10, a factor of 5, which can take care of its life the life of the structure, the damage, then all other issues one should calculate in that. And same thing in permeability also, like clogging is one simple thing that one can occur in permeability. Like if there is a clogging, then what happens, there is no water flow and permeability is going to be quite low. So what we do is that we try to account for that. So we try to provide extra thickness of this material, extra opening, or you try to say take a bigger size than what you got now. So for example, you get a 0.8 mm size because of some calculation. So go for 1 mm size of that material, something like that. So essentially some of these characteristics are quite important, and one should see that they are all incorporated in design. This is a typical example, like see as I just mentioned, many of these materials have time dependent response. So for example, the of course the x axis is not very clear, and y axis is the force, and see some can be very stiff, some can be very the tensile they can go for long strains, and then they can't, some materials cannot they reach the ultimate value in a short span. Okay, the ultimate value you can reach in a short very fast, whereas in some materials it can take time. See, it is a very interesting thing that depending on the type of application you can have both this type of products. So for example, I have one case where the holding of stones is an important criteria. Like if I put a geotextile, you have a geotextile and it should hold a stone, like say for example riprap is placed on a geotextile. Okay, geotextile is there, and then that material can really sag. I do not have any problem, if it can expand, this geotextile can expand, I do not have any problem. Why? Because it should not get punctured, it should not yield, that is the only thing. It can get little these things, it is not an important criteria, but as long as it does not crack and hold that what is the stone pitching or that pebbles, it is alright for me. But in some other applications it should be very stiff also, like this, like so stiffness is if the it is somewhat steeper curves, stress strain curves or the force versus strain curves are given by this, and if it is flat also is okay, like because what happens, the flat ones are the materials that are stiffer are little expensive compared to the ones that have a lesser stiffness, that is one thing, and because of the manufacturing process and all that. So these are all some properties. Ultimate tensile strength, these are again they can have a relationship like this. What I want to just say is that the geosynthetic families have materials have number of supporting organizations. In fact, we so many organizations, Indian International Geosynthetic Society is one, and then we have so many publications and we have journals on this area. Say for example, Geosynthetics and Geomembranes is one, Geosynthetic International is one, and there are so many, and it has been quite extensively used in many of the ground improvement problems. As I just mentioned, Geosynthetic Institute is one, International Geosynthetic Society, then Geosynthetics Materials Association, International Standards Organization like ISO standard, then ASTM International. In fact, there are so many standards also here nowadays, because these materials have all testing standards, and some materials are the thing is we have what is called ISO standards. Say for example, ASTM standards are also there. In America the ASTM standards are popular, and in Europe they have EN standards, EN. So then ISO standards are also there for geosynthetics, and you also have various guidelines developed and proposed by these institutes, International Geosynthetic Society, quite useful in many of the applications. Actually, if you do not use this material properly, again this is useless. So, to use this technique properly, to use this product properly, you should know its technique and its properties. So, to have its properties, you have to have standards, and to see that they are properly implemented, you need to have the technical guidelines. See, these some of the organizations, some companies, they give lot of manufacturing guidelines. So, for example, this is these are all geotextiles, Coir Geotextiles from the jute company. So, they also gave what are the specifications we have, and what are the properties of each material, like say for example, nonwoven geotextile, what are its properties, it is given. Then the other one was that, say you can take any other commercial geotextile, where say for example, there are so many companies in India and abroad, not less than maybe 30 to 50 companies, where they come up with their own catalog, and products like this are given, and their properties are given very clearly, and how to use that in the field is also given. All the designs are also tentatively given, but then you have to cross check with your calculations and actual field conditions, because the forces which are acting in the field, you need to understand and then use this material, whether it is a drainage, whether it is a lateral force, and all that, one should do it properly. Then the publications, like a lot of research is going on in this area. The thing is that there is so much work and research that it is a very innovative thing. As I just mentioned in the beginning, that civil engineer has soil, concrete and steel. Now you have an other material, geotextile or geosynthetic materials, which can be used to construct roads or anything, right. So, you have good journals like Journal of Geotextiles and Geomembranes, Geosynthetics International Journal, then GFR magazine. There is also a standard book Designing Geosynthetics by Professor Korner, and of course, there are also many books which in fact are available, which are generally based on the work that is reported in some of these papers. The other one was that we have even Ground Improvement Journal, that is another important thing, the Ground Engineering Journal. In fact, that is all, they are all given by this is an Elsevier publication, Geotextiles and Geomembranes. This is a it is called ICE, Institute of Civil Engineers publication. Then you have Ground Improvement. There are so many journals one can have, and they are very useful. So, the scenario for the geosynthetic family is that they are quite useful in transportation applications, they are very much useful in geoornamental applications, and they are moving towards hydraulic engineering applications. So, in the sense here some more important thing is that in the transportation geotechnical applications, people have been able to understand that these materials are useful, and then moving towards generic specifications. Okay, in general, what could be that, and the geoornamental applications, they are all regulatory driven. As I just mentioned, even Government of India, say for example, Government of India also has rules on how to construct landfills in India using geomembranes, and all these materials involved with some specifications, and their field performance has been very good, because if you do not use them, we see the contamination immediately. So, field performance has been very good. Hydraulic engineering, yes, it needs a lot of inputs, much more inputs, but it has been picking up very well, and it has a lot of opportunities. In fact, the other day only I was trying to design a 35-meter high wall behind backwaters of Nagarjuna Sagar water, where the water flow is so high, and if you use a conventional retaining wall, it could be very expensive. As I said, you have to design for water pressures as well as the height itself is high, so much 35 meters. So, when I just used a Gabion type, a geosynthetic and type of wall, it was quite effective, not less than 40% it was cheaper. So, actually it was costing 5 lakh rupees per meter length, and including the height and whatever. So, now it is reduced about 2.5 to 3 lakhs, which is about quite cheaper compared to what they had initially. And the opportunities for private development applications, in fact, these geosynthetic materials are so useful that I know some people who are using it for waterproofing in their houses, like private development. There are so many apartments complexes nowadays coming up. They want quick solutions faster, they do not want to have problems facing them and all that. So, in fact, I know many apartment complexes who are using say for example geomembranes for you suppose they have a swimming pool in their developmental area, they need to go for geomembrane, they may go for geogrid. So, apart from the work in the public sector, there is so much encouragement and application in the private areas also. So, what I want to say is that this geosynthetics are bona fide engineering materials and must be treated as such. You have testing methods and designs that are available, and the only thing is that you should understand them properly and design them properly. The basic advantage of the geosynthetic materials is that there is a, it's all quality control products, like they are all ISO certificate, they have, each product has an ISO certificate, which is not easy to get, and they are also once you do in the field, you can test the samples also. So, they are all supported by rigorous quality control programs. The field performance has been excellent. In fact, there are the RE walls have been constructed now about 30-40 years now. See, the first RE wall about maybe 25 years back it is constructed, they are doing well. Geomembranes, in fact, Terzaghi used in 1958 in one of the dam projects, 1958 it is used, for about more than 50 years. So, their prediction, their performance has been excellent. In fact, there are so many applications that imagination is the only limit here. So, people have been able to use it, the thing is that if you are really serious about using these materials, one can, they are very, you have to be little more aggressive in thinking as well as take advantage of these products. Your challenge is to take advantage of these materials and get, number one, the design has to be very good, then its analysis has to be, you must be doubly sure that yes it works for you, provided you install it. So, your property should be very sure, all of them are there. So, its only thing is that one should take advantage of this, and of course, people have been doing it. So, I am sure that in the subsequent classes we will be dealing with some of these materials and their applications. Thank you.